Sketch a graph of the function r equals 3 plus 2 sine theta. First of all, let's take a look at what it means to use polar coordinates. And so the polar coordinates have these coordinates, r and theta. And theta is usually, almost always, in radians. And we will use it in radians for this example. So r, that's the radius. That's the distance from this origin. So let's say we have some distance from the origin, and it's about this far. And then what we're going to do with that distance, you can think of this like a spinner. So we're going to rotate that some theta degrees, or theta radians. So we'll use radians in this case. So we'll rotate that theta radians, and now this spinner is up here. Now we're only really looking at the point. That's this. But this is just how we're getting there. Kind of like in the xy coordinate plane, you go x units and then y units, and you don't draw those lines. I just did those for reference, and then it just plots one point. Okay, so this then would have the coordinates of a radius of, well, it's got 3 in the x direction, 3 in the y direction. So this is 3 square roots of 2. 3 square roots of 2 is the radius of this point. And theta, well, it's a 45-degree angle. Or again, in radians, that's pi over 4. Okay, so that is briefly polar coordinates. Now, sketch the graph of this function. What we're going to do to sketch that is just plot some points. So I'm going to put the independent variable, theta, right next to the dependent variable, radius, in a table, and I'm going to just put down some points. So what if we have 0 radians, or what if we have pi over 6 radians, or next, what if we have pi over 4 radians, pi over 3 radians, and then pi over 2 radians. So that just brings us through the first quadrant. And what happens if we plug in 0 in for theta? Well, you have r equals 3 plus 2 sine of 0. So that's 3 plus 2 times 0, because sine of 0 radians is just 0. So that gives us 3. I'll put that in a different color here. I'm going to put that in green. So 3. So when we are rotating around this spinner, when you have 0 radians, you are at a radius of 3. So 3 units from the origin. Now, you could do the same thing when you're plugging in these points. You've got pi over 6 radians. So 2 times sine of pi over 6 radians, and then plus 3. Well, that equals about 4, or exactly 4. And then I'm just going to write these down. If you plugged in pi over 4 in for theta, then sine of pi over 4 times 2 plus the 3 equals, I'll give it as a decimal, 4.41. And then if you plug in pi over 3 radians, you get 4.73. And if you plug in pi over 2 radians, well, sine of pi over 2 is 1. So you'd have 2 times 1 plus the 3 gives you 5. So I'm going to plot that point right away. When we are at 90 degrees, or pi over 2 radians, that's like this, pi over 2 radians, then we have a point that is 5 units from the origin. 2, 3, 4, 5, right up here. Now some of these other points, let's see, if you're at an angle of about, or at exactly pi over 6 radians, I'm drawing it, I said about because I'm drawing it about pi over 6 radians there, then we would be at a distance of 4 units from the radius. So that line in blue is about 4 units long. Now, plotting the other points, it gets a little bit difficult actually to do this by hand, which is why, let me give you the punchline right away. Usually if you're going to graph something in polar coordinates. You're going to plug it into a calculator or use a software program. But it is important to understand where these points are coming from and what it is that's being graphed. So if we have a 45-degree angle, just like this, well, then we're going to be a distance of 4.41 units from the radius. And I know that looks kind of closer because of the way we think about the XY coordinate system, but really this green line is longer than this blue line, so just a little bit longer. So 4.73 units when we have pi over 3 radians. So that'll be about here. Now, because this is sine, then when we keep on going around to extending theta around, well, what we're going to see is that the left and right sides look the same. So when sine is positive in the first quadrant, sine is positive in the second quadrant. I'm going to erase that, what I just drew in purple, just because I don't want it to get in the way of what I'm going to sketch out here. So the rest of this goes like this, kind of follows this pattern. And I'm trying to give you a nice sketch of this. And then, just in the interest of time, I'll sketch out the rest of this. So if we go beyond this, this is through pi radians here. If we go beyond the pi radians, it kind of dips down and then it comes back up, and it's 1 unit away from the origin. The radius is equal to 1 when theta is pi over, or 3 pi over 2, right there. And then it dips down again, the radius gets a little bit longer, and then it continues to grow all the way out to when theta is 2 pi, the radius is again 3 units from the origin. So that's a rough sketch of this graph in polar coordinates.